We are back for prop logic session. What is it? 9? Yeah, session 9, I
Yeah,
guess. Okay. So let's jump right into it. So last time I sent you a couple of arguments to prove the validity of. So can you tell me what the argument was so that we can quickly go over whatever you tried, and then we can proceed to the rest of the rules of inference.
sure. So the first argument you sent me was based on three premises. So it's Q implies Y for the first one.
Q
No, sorry, X implies Y,
X implies Y,
and then not Y,
not Y.
and then uh, X or Z.
X or Z.
Therefore Z. Yeah.
Okay, yeah, this is very simple. Let's do it. Okay, so I've declared all the. Actually, I should write it this way. Since we are doing a proof, I should write it like this. Um, therefore, set. Yeah,
You need Do you need
the
the three dots, or can you just write
yeah,
Z?
you don't need it. You can just write Z. That's fine.
So then what I did was I declare a new pr pr prem premise,
Okay.
premise number 4,
Okay.
and then using the first two premises
Okay.
and using modus tollens,
Mm-hmm.
I get not X.
Okay. So this is one
One.
comma
Yeah,
two. Um, what was the convention we followed last time? One
just
comma
empty.
hyphen. Yeah, hyphen. One comma two hyphen modus tollens.
Yeah. Last
Okay.
time we wrote P1 comma P2,
Yeah,
but
that's fine.
that's how.
Yeah, it doesn't matter.
Yeah. So then that how do we say that? Do we say we declare a new premise or we create a new premise? Is that a correct
You could
way?
say the next step. That's fine. You don't. Yeah.
Next
Doesn't.
step. All right.
Yeah.
So then the next step after that, using um the premises uh 3
Mm-hmm.
and 4,
Okay.
we uh we use a new rule of inference this time. So we use, I believe it was disjunctive syllogism.
Yes. But what will you get?
So using disjunctive syllogism, I just got Z.
Okay, you got Z, and this is 3 comma 4 disjunctive syllogism.
So then therefore, yeah, the proof is done.
Yeah, so you just write QED. Okay, so that was the
And
first
then
one.
yeah,
So let's do the second one.
second one was E implies F.
E implies F,
Then for the next premise, not F.
not F.
And then next premise, not E implies G and H. Not E implies, and then yeah, in brackets, we got a compound there. So G and H.
Okay.
And then after wait yeah, and then after that we just got our conclusion.
Okay. What's the conclusion?
The conclusion is same thing as the end of that last prop. It's just G and H.
Yeah. Okay.
So
Let's do it.
precedent. Yeah. And then so we create a new premise.
Yep.
And then this one I used again modus tollens.
Okay.
So
So you first
not
tell me what you got and then you tell me which rule you used.
not E.
Not E. Okay. And you used which rule?
Modus tollens
On which two premises?
on the first and the second.
Okay. Okay. What's the next step?
Next step, G and H.
Okay.
And I used modus ponens
On.
on P3 and P4.
Okay. So that's P3, P4 modus ponens. Yeah.
QED.
Yeah. QED. Okay. Yeah. I think you got the first. Um. The
Second one
first.
was a bit harder, but I had to look at it for a few minutes, and then I
Hmm.
got the idea that you can just use the negative E and the compound of G and H. You can just see it, think of it as uh, one proposition, and then you get the form for
Yeah.
modus ponens from that.
Yeah. Okay, so let's do something a bit something that's a bit difficult. Let me look for a question that is okay. Let's try this one. Um, okay, premise one is P implies Q and R. Premise 2 is not Q and R. Premise 3 is P or A. This is easy. I'm not going to do this. Um, let me check. Let me check. Okay, let's try this one. Q implies not R implies S T or Q, not T, R implies T, therefore S. Let's do this.
Okay, let me read through the. Um, Okay, this one's a bit difficult because we have in the second premise we have a new we have one, two, three, four different letters.
Yeah. Try to find an obvious rule of inference being applied.
And do I have to always use it on the first?
No,
Uh,
no, it doesn't. You don't have to.
so I don't have to go in that order.
No, no,
Okay.
not at all.
All right. So then I guess I can see a dish disjunctive syllogism
Okay.
on premise two and premise three.
Okay. What's the conclusion of disjunctive syllogism 2 and 3?
But then just Q.
Okay. Let's try that. 2 comma 3. Oh wait, hyphen disjunctive syllogism. Okay. Next step, next step.
So the next step, I think I can see a one minute. Let me look through the rules. I think I can see another disjunctive. Uh, no. Ah, I can see R to T, not T.
Okay.
Can we do it on premise two and premise? No, premise four. Can we do it on premise three and premise four?
Premise 3 and premise 4. Yeah, you can. What do you want to do?
Um, another modus tollens.
Okay, what's the conclusion?
Oh, not another, the first modus tollens,
Mm.
but uh, not R.
Not R. Okay. So that's 3 and 4.
Yeah.
Modus tollens. No, sorry, 7.
And we use a. Can we do something on premise three? Premise four and premise six. A. Yeah, can we do a modus tollens on premise four and premise six so we get
Modus tollens?
on premise four and premise six?
No.
So modus tollens goes to alpha to beta, then not. But why can't we do a modus tollens on premise 4 and premise 6?
What's modus tollens?
So alpha goes to beta,
Mm-hmm.
and then not beta, not alpha.
What's alpha and beta here?
Oh yeah, that doesn't work then.
Mm. You got this, right? This one. Um, what can you do? You see any use for this?
I was looking at uh I no, for the moment. For the moment, not too much for the Q.
Why not?
Because I'm not sure how I can combine it with the first premise or the second one.
Okay. Like Q in the first premise, what would that give you?
Ah, okay, so we can actually we can use
Yeah.
the modus ponens,
Modus,
right?
which one? Modus what?
I would say modus ponens.
Modus ponens, yeah.
So then, yeah, so then it's just not R implies S,
Yes.
and
What's
then
this?
we're doing it on premise 1 and premise 5.
Okay, modus ponens. I'm writing the next one here. Um, okay. Now?
Is I'm guessing we're gonna have to do something with the premise 6 and premise 7.
Yes.
Can we use a modus ponens on it?
Yeah, you tell me. What would you get with modus ponens
So
here?
not R implies S. Then we
Mm-hmm.
have not R, so therefore S. Yeah, we have
Okay.
S,
Okay.
and we did it on 6, 7 modus ponens, and therefore we've done the proof.
Okay. QED.
Okay, that was a step up.
Yeah, that was much better. Um, yeah. The thing is, you should sort of memorize the structures of all of the four inference rules. Um, so that like you don't have to keep referencing back to the list. Like you should um, like ideally what you want is you should look at this and feel okay, that's a disjunctive syllogism, you'll get Q. Okay, you got Q, and this is going to be a modus ponens, so you'll get this. But you have this, you can use a modus ponens here, you'll get not T, sorry, not R. And then you can apply modus ponens here and you can get um, like a modus ponens there and you can get S. So that's the kind of way you should be thinking about it.
Okay, I guess it's just practice.
Yeah. So like the point I'm trying to make is that you shouldn't have to reference the rules over and over again. You shouldn't be looking at the list again and again. Like you should be like sort of memorizing these patterns. So this pattern
Cool.
is a disjunctive syllogism. This pattern is a modus tollens. Um, then Q and this pattern is like a modus ponens. This is a modus tollens. Um, you know, so on and so forth.
Yeah.
Yeah, I guess that'll come with practice. Okay, so what do you want to do? Do you want to do a few more examples, or do you want to do the next four um, rules?
I guess we can go straight into the next four.
Okay, yeah. So I'll copy this and I'll paste this. Okay. Okay. What's the convention? Yeah. Okay. Okay. Yeah. So we are at um, number 5. This is a simple rule. This is called conjunction. Conjunction, you can also say conjunction introduction. Like I mean, it's like not an interchangeable name, but like both together. Why is my conjunction introduction? Okay. If you can just write conjunction, I won't mind. Um, so this looks like alpha, beta, therefore alpha and beta. Okay, makes sense. Alpha is true, beta is true, therefore both alpha and beta are true.
Yes.
Okay, makes sense. Yeah, so this is very simple. um, then the next one is addition. Oh, sorry. Addition. Okay, so again you have yeah, this is also called implication introduction. Sorry, no, a disjunction introduction. Disjunction introduction. Okay, you can just say addition, it's fine, I won't mind. P1. So here you have alpha. Okay, and you directly have a conclusion which is alpha or beta. This is the rule. The reason this works is if alpha is true, right? Then in a conjunction, at least one sorry, in a disjunction, at least one disjunct is true. So this disjunct is true. So there's no way for the premises to be true and the conclusion to be false. You know?
Yeah.
So that's why this rule also works. Did I cover the previous one? Um, Yeah, so let's do this. So this is true, okay, this is true, this, so both of them have to be true, and when both of them are true, the entire conjunct is true. So there's no way for the premises to be true and the conclusion to be false. So that's how the previous one also works. um, then you have number 7, which is uh, should I do constructive dilemma first, or should I do um, the other one first? I can do constructive. Okay, I'll do simplification. It's fine. Simplification is simpler. Simplification. This is called conjunction elimination. Okay. Can you guess what this means?
That you're getting rid of a conjunction somewhere. So you're starting with a conjunction, then
Okay.
and I'm guessing it's just alpha or
Yeah, it could just be alpha. It could also be P1, uh, alpha and beta. Uh, and conclusion can just be beta. It could be either of them. So this is conjunction elimination. And the last one, a bit tricky, is called constructive dilemma. Constructive dilemma. Wait, why is my pen? Okay, yeah. Constructive dilemma. Okay. Yeah, it's, so this is going to be P1, alpha implies beta, P2, gamma implies delta, P3, alpha or gamma, conclusion beta or delta. Okay.
yeah.
There's also a variant of this. So if you notice something, this is actually like similar to modus ponens. This is related to modus ponens. So you have two conditionals, and you're saying at least one of the uh, antecedents is true, and the conclusion is at least one of the consequences is true. You see the pattern?
I don't really understand what you mean by when you say at least one of the antecedents is true and one of the consequences is true.
Okay, so here you have two conditionals, right?
Yes.
And each conditional can be split into an antecedent and a consequent. So for example, this is an
Yeah.
antecedent, this is a consequent. You remember that?
Yeah.
So when you take both of these conditionals, at least one of the antecedents is true, because that's what a disjunction means, right? A disjunction means at least one of these two is true.
Yeah.
Both could be true, but at least minimally, at least one of them is true. Either you could have alpha is true, or you could have beta. Sorry, gamma is true. So when at least one of these two is true, you know, you also have at least one of these to be true. Are you
Yeah.
following?
I guess yeah, you'll be able to illustrate that using the truth table, but yeah,
Yeah,
I'm not
we
gonna
can I can show you with the
that's yeah.
truth table, but I also want to I want you to intuitively see this. So look, we have two conditionals, right?
Yeah.
Now, like out of these two conditionals, at least one of the antecedents is true, right? That's what this
Mm.
means. That's what this means.
Yeah.
So let's say alpha is true. So if alpha is true, you get beta by modus ponens. And let's say this is false, okay? Then this would also be true. So beta and delta both are true. Um, and because of beta and delta both being true, this is true. So like, I mean, it doesn't matter what this is. So if alpha is true, then beta is true, modus ponens, right?
Yeah.
And at least one of these is true. If beta is true, then the disjunction is true, regardless of whether this is true or false.
Yeah.
So if at least one of the antecedents is true, then at least one of the consequents will be true.
Yeah.
You getting that?
I think so.
Okay, can you say that back to me so that I know you get it?
So you're saying that if one of the antecedents is true,
Yeah.
then it will mean that in the premise P3,
Mm-hmm.
then alpha will, if at least alpha is true, then the whole P3 will be true as well.
Yes. And
So that's what I so that's what I got.
okay, and if alpha is true, what do you get?
So if alpha is true, then at this bit I'm not following.
Okay, so if alpha is true
Yeah,
and this is true, alpha implies beta is true.
yeah.
What rule of inference is that?
Modus ponens.
Modus ponens. And what do you get as a result of modus ponens?
Uh, well, you just get if modus alpha implies beta. If you have alpha, then you have beta.
Yeah. If you have alpha, then you have beta. So what's the conclusion?
The conclusion is beta,
Beta.
right?
Okay. And if beta is true, then beta or delta is true, because one, you just need one of the disjuncts to be true.
For in the disjunct for the whole compound to be true.
Yeah.
Hmm.
So you got that?
Yeah, I think so.
Okay. So all I'm trying to say is that this is like a double modus ponens, sort of, So these are two conditionals, and you have like these two. So you have like you can modus ponens on at least one of them, and you get this conclusion.
Hmm. But yeah, but if you have alpha as true,
Yeah.
right, in premise one, for the beta cannot be false, right?
Yeah.
Because then that will make the whole compound false.
Yes.
So when alpha is true for that whole compound to be true, then beta is also true.
Yes.
Hmm. And then
So
when you have beta true, then uh, then in the conclusion, beta will also be true as well.
Yes.
And then because it's disjunct,
Yeah.
and then that will be the conclusion will be true regardless of what the other disjunct is.
Okay. Yeah. So that's like a so this is like a modus ponens version. Modus ponens version. Okay. Then you can also have a modus tollens version.
So I'm guessing the modus tollens version would be something like yeah, we would have the first two premises the same as before, or
Yeah. Wait, that looks like
except
a and that looks like an 8. Okay. Yeah. What will be P3?
P3 would this time we'll be taking the ones on the right hand side, so the consequence. So
Okay.
it'll be like not beta,
Okay.
and then we have an or, and then what what was the name of that? That's
Delta,
sigma or
delta, delta. So
so not
that's
delta.
not delta. Okay.
And then for the last one, for the conclusion, we would have uh yeah, not alpha,
Mm-hmm.
and then again or not gamma.
Yes, exactly. So constructive dilemma comes in these two variants. Um, yeah. So those are the 8 rules of inference that you can use to basically prove any theorem in prop logic.
Nice.
Yeah. So we can do something. We can try out a couple of proofs using these 4. But the thing is, you also have to use the previous 4.
So it becomes difficult.
Yep. Let's try something simple first. A implies B and C. Not. Yeah. Okay. Yeah.
So I'm
So
going to try and do it without looking
yeah,
at.
don't look at the list.
So, so just using my gut instincts,
Mm-hmm.
then I guess that looks like a modus tollens.
Okay.
So then it will be not A.
Not
I
A.
guess.
Yeah. 1 comma 2 modus tollens. That's right. Okay. So that's QED. Um, let's try the next one. Um, okay, this is a bit long.
So you're getting these from the Russell Marcus book, these examples.
Yes, exactly.
Which page?
1 second. 122. 122.
Um, I'll check what page you are on. Are there lots of questions which people can try in this chapter on this book?
Yep, there are lots. Back in my house, I have a notebook that has solved all of these questions.
All right, so I'll use the writing.
Yeah.
All right, yeah, there's a lot of questions.
Sorry.
But something good. It's something good which you can do when you're on the train or
Oh,
just a bit
yeah,
of fun.
absolutely. Okay, let's start.
So I'm guessing I,
Mm-hmm.
I would say if I just look at P1 and P2, I see
Mm-hmm.
um is this the fourth rule which we haven't touched yet? Maybe.
No, we have touched it last time.
But we haven't is
Oh, we
this
haven't used it today. Yes.
so it looks like then it's a hyper hypothetical syllogism.
Mm-hmm.
So
What's
then
will this be?
so then it's if I remember correctly, then it's we have in brackets we have D or E implies G or G by conditional H. Uh, is that correct?
Yes. What's the rule?
What was the one? Hypothetical syllogism. HS.
Okay.
So
You don't need to do that though.
I'm just. Is this? I would say because it looks like P3 and 4. I'm not looking at my notes. I think it could be a disjunctive syllogism, maybe.
Which one?
But I'm just guessing here.
No,
P3 and
it's not a disjunctive syllogism. Disjunctive
is that
syllogism is when one of the disjuncts is false, so the other disjunct is true.
so then just off the top of my head, are we using one of the first four rules or one of the new ones we've learned?
That doesn't. I mean, it shouldn't matter at this point. You know all the rules.
But yeah, but I'm not that familiar with all of them,
Yeah.
so maybe I'll have to look through the rules then.
Okay, the hint is we did it today.
Okay. If we did it today, I'm guessing then it's the last rule we did.
Yes, okay. So where will we apply that? So I'm removing this because you don't need this.
Oh yeah. So it was pretty useless what we did there.
Yeah.
Okay, so then I'll take a brief glance at the constructive dilemma.
Mm-hmm.
This one's a bit different because uh, before the other rules are all based on two premises we were doing and we were constructing it, but
Yeah,
in the constructive dilemma here we have three premises.
exactly.
So yeah, that's something new.
Mm.
So let me uh, yeah, I think I need you to walk through me this one just so I can see how to put the constructive dilemma in practice.
Yeah. So this is just look. So this check this out and check this out. Let me use a different color so that it's visible.
Okay, so we can call that D or E alpha, for example.
Yes.
And then the F will be will the F be gamma or beta or delta?
Does it matter?
Because in the one we did in the constructed dilemma we had
Separate
alpha
ones.
we had alpha implies beta, and then the third premise was alpha or gamma. So,
Mm.
but in here, F is the same in both
Yeah.
cases. So I don't know. I'd be a little bit more comfortable if F was different in one of P1 and P3.
Mm. Okay, if it was different, what would you have done?
So if it was different, then I would, for example, if F was G in P3, then I would have at least something which resembles P1 and P3 from the constructive dilemma. And then, uh, wait a minute. Uh,
Think of it as a modus ponens, right? So you have this, okay? You have this, and you have this. So these are the antecedents in this. So what's constructive dilemma? So the
okay,
antecedents are
so
true.
yeah.
So what does constructive dilemma say?
So the constructive dilemma says that if one of the antecedents is true,
Mm-hmm.
then then any one of the yeah atomic propositions in P3, as long as that's true, then the whole proposition will be true.
Mm-hmm. It doesn't have to be atomic, but yeah.
Yeah, but or what I mean is like the consequent or the what was the antecedent.
Yeah.
So so yeah, so that works out
Yeah. So here the antecedents are true, and
yeah
constructive dilemma says what?
that if one of the antecedents is true,
Then.
then the the disjunction proposition will also be true
Disjunction of what?
of of the two antecedents.
Mm,
So
yeah.
in P3 we have the two antecedents, a disjunction from them, right?
Yes.
So then P3 is also will be true.
P3 is true, but what does constructive dilemma say when these three propositions are true?
Okay, so all right, so when the three are true, then the consequents are
Mm-hmm.
both going to be well, is it the
Not both, but at least one of
well,
them.
the disjunction from the consequence will be true.
Okay, yeah, we're getting there. So what's the disjunction of the consequence in this case?
Okay, so it's F
Mm-hmm.
or then the biconditional of G and H.
Yes. And what's the rule? Okay, well, you applied this to 1, 2, and 3, right?
Yes. Even though we didn't really do much with the third uh, premise.
No, you applied constructive dilemma on the third premise. So treat this as alpha, okay? Treat this as alpha,
Yeah,
treat this as beta, treat
yeah.
this as gamma, and treat this as delta. So what if they are the same, right?
Okay, but F so we're treating F in P well F as the consequent in P1 it's beta, right?
Yes.
And then F as the antecedent
Yeah.
in the P2 it's not beta anymore, we're treating it as gamma.
Yes.
Okay.
Like this. Treat this like this. Alpha implies beta, gamma implies delta, alpha or beta, and then you get what? Sorry, alpha or gamma, then you get what?
Uh, well, what we just wrote for P4. Uh,
Mm-hmm. What's that?
so F or biconditional.
Yeah, but
Oh,
what
so you mean
is, yeah,
in terms of then we get,
metalinguistic variables, yeah.
yeah, in terms of metalinguistic, then it's beta
Okay. Or,
or um, delta, right? Is that
yes. So that's constructive dilemma right there. It doesn't matter that these two are the same.
okay?
So you could assign different metalinguistic variables to the same thing. It doesn't matter as long as it is
Okay,
done for a proof. Yeah.
right. I was unaware of that.
Yeah. Uh, so okay, so okay, where do we go from here?
So yeah, we write down C D that we did a
Yes.
constructive dilemma.
Okay, yeah. C and D. Anything else? Oh, sorry, I should add a biconditional here.
So we've got it right.
Yeah. That's QED.
Yeah, so we write QED.
Yep. Let's do one more. Mm, find a nice question. Okay, let's try this. This is easy, very straightforward. O implies Q. Q implies P.
For the last question, should we make a note that we did the constructed dilemma modus ponens or version, or does it not really
Doesn't,
matter?
nah, doesn't matter. That is just for like illustrative purpose. Okay, let's go.
I'm guessing that it looks like another constructive dilemma.
Hmm? Why?
Are you still there?
Yeah, I'm here. Hello, hello, can you hear me?
Yeah, I can hear you.
Okay, yeah. Why would we do a constructive dilemma?
I don't know, I just saw two implications in the first two.
Okay, but then did you see a disjunction after that?
No disjunction after that.
Then how will you apply the constructive dilemma?
Okay, so that rules that one out.
Mm-hmm.
Uh, I know this one we can use the one we did use last time, the hypothetical syllogism.
Yeah. So tell me, what do I write?
So last time, how did you know the construct? Well, the what was it? The hypothetical syllogism. How did you know that it wasn't useful? Because you rubbed it out.
Oh, I just saw the constructive dilemma. It was a one-step proof.
Okay. But from the in the last one, could we have done something after with the hypothetical syllogism
Uh,
to
I guess, but that will make it like make the proof really long, I guess.
all right. So I guess we can skip that.
Yeah. I mean, you can try that for homework, I guess. Try using everything other than constructive dilemma to prove this.
Cool, yeah.
Yeah, I think that'll,
Okay.
yeah, it'll be a bit difficult, but yeah, you can try. I won't stop you.
Okay.
Don't use constructive dilemma, just use everything else.
Cool. So then this one, O implies P.
Oh, sorry, one sec. Mm-hmm.
Yes, then we have yeah, 1, 2, and then dash HS.
Okay.
So for this one, not too sure. Uh, uh, could we do it on P2 and P3?
Mm, yeah.
So we get Q implies R and S.
Yeah, but you don't need to do that. It's a redundant step.
Okay, so it's not then P2 and P3.
You can do it, but the thing is, it will be like it won't be a useful step. Useful in the sense that you can do the proof shorter. Like, like obviously you can use that, you can add that as a step, but you can have a shorter proof with less steps without using that. You're like 2 steps away.
I got feeling that would be something to do with P3 and P5,
Yeah.
but at the moment I cannot see. So, I can't see it being any of the first four.
Hmm. It is one of the first four.
Okay, so I'm not looking at my notes. I'm just gonna walk through, like, speak them out loud
Yeah, sure.
and see if it's any one of the first four. Okay, so the first one is modus ponens. Could it be modus ponens? So modus ponens is P implies something. Then we don't we. So it cannot be modus ponens. I'm pretty sure.
Okay.
So after that, we don't have a negation, so it cannot be modus tollens.
Mm-hmm.
And then uh, it cannot. Uh, I don't think it can be a disjunctive syllogism.
Obviously. There is
And
no
then
disjunction.
and then can it be a hypothetical syllogism? So P implies something, then that something implies P.
No,
So
that's not hypothetical syllogism.
so, so what I have for hypothetical syllogism is that last time I got it from the internet, but it's P implies Q, Q implies R,
Hmm.
therefore P implies R.
Yes, that's correct.
So so here we have P implies R or S,
Mm-hmm.
and then we would need R or S to imply something in another premise.
Why?
Because that's the two. That's what I have. I have
You
a
could have
P
something
implies.
implying P.
Okay. Um. All right. So we're going just the other way around. We're going. Yeah. I always. Yeah. Going. Yeah. I'm going from P5 to P3.
Mm-hmm.
So O implies P, then P implies R or S.
Mm-hmm.
So then, it's O implies implication R or S. Well, and S.
Sorry. Yeah.
I said all, but conjunction, and then we did it on 3 and 5. Again, a hypothetical syllogism. Yeah, so yeah, that one was tough because uh, yeah, I don't think we've worked back the other way before.
Mm, yeah,
But normally we're working uh, in ascending order of the numbers. So here we were
yeah.
going backward. Yeah. That's something new. So then we've got well, not yet actually. We haven't got R or S, so we need to work out what we can do next.
R and S.
R and S, yeah. So let me have a look.
No, don't take a look.
Well, I mean, I'm having a look on the
Okay,
screen.
okay, okay.
Yeah. Um, okay, I think we can do a
Mm-hmm.
modus ponens
Yes.
on 6 and 4.
6 and 4. Okay, what do you get?
So it's just raw S, R and S. And then, yeah, we have 6 and 4. The one above, should we write 5-3?
No, doesn't really matter.
Okay. And then we've got done the proof.
Yep,
So QED.
yep. Yeah, that's all.
Yeah. So I think I can get this with some practice.
Yeah, it'll take some practice, but yeah, you'll be able to get it.
Because yeah, now that I realize that yeah, we can work the other way.
Yep.
Cool.
Yeah,
Does that
I think that should be good enough for today.
yeah, but yeah, I think that's yeah, pretty good that we've covered all the rules.
Yeah.
Need to yeah, just practice makes perfect, they say.
Yes, that's right. So we have covered all the rules, and there's a bunch of rules that we haven't used yet. We haven't used addition yet. We haven't used simplification yet. Um, so yeah, I guess it's something to use in the next ones.
So we'll have a part 3
Yeah.
of rules of inference.
Yep.
Trilogy.
It won't be a rule of inference part, but it would just be like some more practice and all of that.
Sounds good.
Yeah.
All right then, yeah, we can call that.
Yeah, we can call it a day. And catch up next time.
Perfect. See you soon.
Yeah. I
Yeah.
am ending the recording.